Today we're going to talk about properties of rational exponents and radicals. So first we're just going to cover some basic properties. So if two numbers have the same base, in this case 2, we can add their exponents in order to simplify. So we just do 2 to the 5th, which is 2 plus 3. Whenever you have a number raised to an exponent and then that is raised to another exponent, we call it power to power, you can multiply the exponents. So this would be 2 to the 6th, 2 times 3. In this case, if you've got two different bases with the same exponent, you can put the bases together and raise them to the power. 6 squared, which equals 36. Whenever we have a number to a negative power, we simply put that number in the denominator, so we're left with 1 over 25. Anything raised to the 0th power is 1. If we have two numbers with the same base and divided, we can just simply subtract the exponents. So 5 minus 2, we're left with 5 to the 3rd, which is 125. And whenever we have a fraction raised to an exponent, that exponent goes to both numbers in the fraction. So we're left with 7 squared over 3 squared, or 49 over 9. Moving on, we're going to use these properties to simplify expressions. In this first case, we can take our 5th power and apply it to both the numbers within our multiplication. When we do this, our first term, because we have power to power, simply multiplies the exponents, and we're left with 5 times 8 to the 5/4. And we can leave it like that for right now. This problem, we basically have 8 to the 1 in the top, so we can just subtract our exponents. We've got 1 minus 8/9, and we're left with 8 to the 1/9. This problem down here, what we can do, because we notice that 6 is a factor of 42, it would be smart to pull out our 1/3, our common exponent, not leaving off our squared. 42 divided by 6 is 7, so we're left with 7 to the 1/3 squared. And then we can simply simplify that to 7 to the 2/3. In this last case, because they have the same base, 7, we can simply add our exponents. So 7 to the 3/2 plus 7 to the 1/2 is just 7 to the 4/2. 7 squared, which is 49. We're going to continue to simplify. So in this case, because whenever you have two numbers that are under radicals divided by each other, you can put them under one radical. We can write this as the square root of 27 over 3, which just simplifies to the square root of 9, which is 3. Once again, 3 is a factor of 27, so that's kind of an indicator to do that. When you have numbers that are under the same radical, we can multiply them together. So we can just do the cubed root of 4 times 128, which is 512. 512 simplifies to 4 cubed times 2 cubed. So then we can pull out a set of 4s and a set of 2s, and so the answer to that is just 8. In this case, this is another problem where 6 is a factor of 192. So we can write this as the 5th root of 192 divided by 6, which is the 5th root of 32, which is simply 2. Once again, with these, we want to continue to simplify. So we can write this as the cubed root of 125 times 4, which is 5 times the cubed root of 4. Easier problem, just to look back. In this problem, our first thought might be to put them under the radical, the fourth root, but you'll notice 4 is not a factor of 19. So we're going to do something different instead in order to rationalize our denominator. What we're going to do is that we know that 4 is 2 squared, but we want a group of 4 to take out of our fourth root, so we lose our fourth root in our denominator. So what we're going to do is we're going to multiply by the fourth root of 4, which is 2 squared, because then we're left with the fourth root of 76 over the fourth root of 2 to the fourth, which is just the fourth root of 76 over 2. In this problem, once again, we just want to simplify. So the cubed root of 162 can be written as the cubed root of 27 times 6, which can then be written as 3 times the cubed root of 6, because 27 is 3 cubed. This problem is like the problem 2 before it. We have the fifth root of 9 in the bottom. That's 3 squared, which means we need 3 more 3's in order to pull out a fifth root. So we're going to multiply by the fifth root of 3 cubed over the fifth root of 3 cubed, which then leaves us with the fifth root of 675 over 3. Okay, in these problems, we're going to multiply by the conjugates. So in this first one, we're going to multiply by the square root of 7 plus 2 over the square root of 7 plus 2. When we multiply that out, we get the square root of 7 plus 2 over 7 minus 4. I got to FOIL out that bottom. We get the square root of 7 plus 2 over 3. We're going to do the same thing in the second problem. We're going to multiply it by the square root of 8 minus the square root of 7 over the square root of 8 minus the square root of 7. When we distribute all of that out, we get 2 square roots of 8 minus 2 square roots of 7 over 8 minus 7, which is just 1, left with 2 square roots of 8 minus 2 square roots of 7. In problems like these, if they have the same radical or the same number raised to the same exponent, we can simply just add the coefficients. So in this case, this would just be 8 times the sixth root of 36, because we have 1 plus 7. The same thing happens in this problem. We're left with 11 times 7 to the 1/3. This next problem is kind of multiple steps. Because we've got numbers with the same bases here, we can simply just add the exponents, at which point we are left with p to the 3/4. And then over here, we know that 16 is 2 to the 4th, so we can pull out a 2 times the fourth root of p cubed. This can be rewritten, though, as p to the 3/4 minus 2p to the 3/4, and then we're just left with negative p to the 3/4. In this bottom problem, we're simply going to simplify both terms. So we can pull out a p from the first one, so we're left with 16p times the fourth root of 3p squared. And then in this case, we can pull out a 2, so we're left with 2p times the fourth root of 3p squared. can subtract those, and we're left with 14p times the fourth root of 3p squared. Moving on, this is another simple one. Same radicals, so we can just add them. We're left with 8 times the cubed root of x. In this case, we need to make sure they're the same radicals, so we're going to simplify our cubed root of 128 to 4 times the cubed root of 2. So now we're just left with 3 times the cubed root of 2. Okay. In this case, we're just going to pull out what we can. So the cubed root of 27 is 3, and we've got 4 sets of 3d's, so we can pull out d to the 4th. In this case, we can rewrite this as the 6th root of x to the 6th over the 6th root of y to the 12th. This is the absolute value of x whenever we have a variable raised to a power, and then that same root is taken. So in this case, 6 power and then 6th root. We need to take the absolute value in order to preserve the answer. This is only true of even numbered powers and roots. And then in the bottom, we're left with y squared. In this case, we're just going to pull out one thing at a time. So we can pull out 2a squared times the absolute value of b, once again utilizing that rule, times c cubed times the 4th root of 3a cubed times c. This problem is just like the ones we did with numbers. We need to rationalize the denominator by multiplying. In this case, we're going to do the cubed root of y squared, because then we are left with the cube root of y to the 15th in our denominator, which is just y to the 5th. And then in the top, we are just left with x squared times the cube root of y squared. Moving on, in this case, we're just going to one thing at a time. So 16 divided by 8 is 2. X to the 1 over x to the 2/3. Remember, we can subtract our exponents. So we have x to the 1/3 times y to the 1/3. And then when we have a negative exponent, we flip it. So normally if it's in the numerator, we flip it to the denominator. Because this is in the denominator, we're just going to flip it to the numerator. And that's your answer. In this case, we want to simplify, so we're left with the 8th root, and we're going to subtract our exponents. So we've got n to the 16 times p to the 8th, and when we simplify that, we're just left with n squared times the absolute value of p.